All right, we are going to look at a worksheet from 2.3, and then after this worksheet we'll work through a bunch of examples that will actually cover 2.3 and 2.4. So this is all for homework 8, and let's go ahead and dive in. I want to encourage you though, if possible, to hop over to Teams. You'll find this worksheet posted in handouts. Print it off, and then every section we come to, it's really important that you try and work it out without watching the video first. So we're going to try to make use of our pause button a lot on this video. So let's just work through this together. I'll do it with you, but I really need you to be engaged thinking about these things yourself. And that's what this whole worksheet is designed to help you do. So I want to begin, and I want to think about, what does the graph of a constant function look like? See if you can answer that question yourself. So you've heard me state several times that the tangent line to a line is the line itself. We've mentioned that in class a few times. So use this fact, or this conjecture, use this to conjecture a formula for the derivative of a function equal to a constant. And so let's think about it together. Pause the video and see what you think the derivative of a constant should be. Let's pause the video. So constant functions look like horizontal lines. And if the tangent line to a line is the line, then the derivative is the slope of this horizontal line, and horizontal lines have slope 0. So our guess is, we can write it here, our guess is that f prime of f prime of x should just be 0. Now we're asked to prove this using only the definition. So I want you to try. We're going to start with f prime of x, and we know that in general this is the limit as h goes to 0, f of x plus h minus f of x all over h. And I want you to take it from here and see if you can work it out. The key to this problem is realizing it doesn't matter what you plug in, f of x always spits out a c, and so you just end up with the limit as h goes to 0 of c minus c over h, which is, technically speaking, the limit is h goes to 0 of 0 over h, and at some point you can see that's just 0. Now here's a point where students often have a very good question, and the good question is, hey, h is going to 0. Isn't this limit of the form 0 over 0? And if so, that's indeterminate, and what am I supposed to do? So I want you to stop now and think with me about the y value output, okay? H is not 0, it's going to 0. And when you have 0 over something, I don't care how small it is, as long as the bottom thing isn't 0, then 0 over anything is 0. So the y values here are 0, 0, 0, 0, 0, 0. They're always 0. And so that's why the form is not 0 over 0. The form 0 over 0 means the top is going to 0 and the bottom is going to 0 at the same time, and anything can happen there. The top isn't going to 0, it is 0, and that means the whole thing is 0 every step of the way. All right, great job. So let's go ahead and write this out in notation. So we've got it here. If f of x is c, then f prime of x, we learned, is 0. When the Leibniz notation, d dx of a constant is always 0. Now I want you guys to take the derivative of this function, pause the video, see if you can do it. What do you get? Well, it's really easy for people to start using things they've seen in high school. Maybe say the derivative is something like that plus something like that, and then they get really confused with this part. But none of that is what you do here. You need to realize this is just a really big number. This is a number plus a number minus a big number. So this whole thing is a big negative number, and so you instantly know that g prime is 0. No need to do any other computation. All right, so I'm going to break this video here, and then we'll go to the next page in the next video.